So, hello everyone. I am Azima Muhammad Ali Jamadar from second year AITS department at Anna Sahib Dange College of Engineering and Technology, Ashta. So, today I'll talk about knowledge representation in AI, how AI systems actually understand and use information the way humans do. This is table of content for today's talk. So, in this short talk, we learn what knowledge representation or KR means, why it's important, the main techniques used, the types of knowledge in AI, and where the KR techniques or KR is applied. By the end, you'll see how knowledge becomes the heart of intelligent behavior in machines. So, AI systems work with data, but data alone is not intelligence. Knowledge representation converts raw data into structured knowledge that machines can reason with. It helps an AI system draw conclusions, make decisions, and adapt, just like we humans do when we learn from experience. So let's see the brief history of knowledge representation in AI. The idea of representing knowledge began in the 1950s. Early AI used simple rules and logics. Later, expert systems and semantic networks were introduced. And today, modern AI mixes logic with learning. We call that neurosymbolic AI, where reasoning meets deep learning. So, what exactly is KR? It is a method of encoding and organizing information so that a computer can use it meaningfully. Think of it as a bridge between data and intelligence, turning numbers and text into understanding format. So, here's a simple way to remember it. AI equals to knowledge means what it knows. In addition to it, intelligence means how it uses that knowledge. For example, a self driving car knows traffic rules and road layouts. That's the knowledge which it has. When it plans the safest route, then that's intelligent. So both must work together. So AI uses several ways to represent knowledge. These are four main techniques used in knowledge representation. So let's look at them one by one. So the first is logical representation. It uses propositional logic, such as true or false, and first order logic, in which variables, quantifiers, or we can even say syntax and semantics are used. For example, if we take all humans are mortal and Einstein is a human, then Einstein is a mortal. So this becomes a true statement. Whereas if we see a contradictory example, Einstein is intelligent, Einstein is a human, then all humans are intelligent. That is not a true statement. So it is false. So let's move to the next technique, which is semantic networks. It connects ideas like cat is an animal and has a tail. It uses is a has a type of connectors. It is easy to visualize. So the next is frame-based representation. It stores information in templates. There are two types in frames, simple frames and inherited frames. Let's take an example. A person is a simple frame which may have name, age, occupation, these attributes, whereas a student is an inherited frame from the person frame, which has all these of attributes, which has all these attributes, but it is an inherited frame from the person. So the last one is production rules. It represents knowledge with if-then rules. It has two types. The first is forward chaining, in which the conclusions are derived from the initial facts which are present. And the second type is backward chaining, which is goal driven reasoning, which means we initially have the conclusion or goal, then we'll derive the facts which are possible. So each technique helps AI reason in a simple, structured way, depending upon the problem. So AI doesn't just stores the knowledge, it keeps improving it. The knowledge representation cycle goes through five steps. The first is knowledge acquisition, in which we acquire the data. The next is knowledge representation, in which we represent the data or knowledge which we have. The next is knowledge inference or reasoning, in which we make use of the knowledge. The next is knowledge application. Last one is knowledge updation. And this is a cycle which forms a perfect AI agent. This loop lets AI learn continuously, just like humans refining their understanding over the time and experience. So let's see the characteristics of good KR system. A good KR system should be accurate, quick, consistent, expandable, and reliable. For example, Google Maps instantly updates routes when roads are closed. That shows an efficient and adaptive knowledge system at work. So AI works with five kinds of knowledge. Let's see them one by one. The first is declarative knowledge. It uses facts and information. Likewise, for example, Paris is the capital of France, or mathematical formula. Next is procedural knowledge. It uses steps or methods like how to drive a car. In a self driving car, applying rules for lane changes and navigation is a type of procedural knowledge. The third knowledge is meta knowledge. It is knowledge about knowledge. It is knowing how to manage other knowledge. For example, an AI vacuum cleaner. It analyzes its cleaning path and adjusts its route according to the better performance. It will check whether that part is already being cleaned or not. The fourth type is heuristic based knowledge. It is experience based rules of thumbs used for quick decisions. Basically, we apply some rules to solve the problems. For example, and Chess AI applies heuristic rules to choose the best move possible. And the last one is structural knowledge. It shows relationships between ideas. For example, we take an example of medical system. There is linking between symptom, then diagnosing the disease. Then we apply some treatment, and the outcome is monitored. So this is a structured way of knowledge. Together, this all allows machine to reason and plan and learn effectively. So building search systems isn't easy. AI faces challenges like incomplete data, contradictions, and updating information in real time. It may be biased sometimes. But even without care, AI would only process data blindly. It would not have any of the outcomes. So it couldn't truly understand or decide what to act upon. So that's why KR is called the backbone of the intelligence. So knowledge representation is used in many areas. Some of them are medical diagnosis, robotics, chatbots, self-driving vehicles, and education systems. Looking forward to the future trends in KR, AI will combine symbolic reasoning with machine learning, automatically extracting knowledge from the web, and maybe even used in quantum computing for faster reasoning. So the goal is clear: make AI smarter and more explainable and more humanized. So, to conclude the talk, knowledge representation gives AI its real power. It turns simple data into understanding and action. It's not just about storing facts, it's about making sense of those facts. The journey of AI truly begins with how we represent the knowledge. Thank you for listening to me.